Today's topic is test for convergence of improper integral of first kind. So basically, আজকে আমি comparison test discuss করব. Previous lecture আমি discuss করেছি what is improper integral, types of improper integral. So basically, improper integrals are two types: improper integral of first kind, improper integral of second kind. So আজকে আমি test for convergence of improper integral of first kind discuss করব. So আজকে আমি discuss করব comparison test. So it is a very important test. Okay. So first write down comparison test. Comparison test. Okay. So first write down the statement. So let fx and gx be two positive functions, be two positive functions and bounded, and these two functions are integrable in the interval this. Okay. Then number one, if fx less than or equal to gx for all x greater than equal to a, and integration a to infinity fx and integration a to infinity gx dx, this is convergent. Then integration a to infinity fx dx is also convergent. দেখো তোমরা যখন সিরিজ পড়েছিলে কম্পারিজন টেস্ট পড়েছিলে, কম্পারিজন টেস্টে কি ছিল? টু সিরিজ, সাপোজ সামেশন un and summation vn be two series such that un is less than or equal to k into vn. What is k? K is a real number. Okay, k is a positive real number. Take if the series summation vn is convergent, then summation un is also convergent. Okay. And if un is less than or equal to k into vn, okay, and summation vn is divergent, then summation un is also divergent. So same concept এখানে, ঠিক? দেখো fx less than equal to gx, if integration a to infinity gx dx is convergent, then integration a to infinity fx dx is also convergent. Okay, so this is number one. Number two, if fx is greater than equal to gx for all x greater than equal to a, and integration a to infinity gx dx is divergent, then integration a to infinity fx dx is also divergent. Okay, দেখো same concept. If un less than equal to k into vn, here fx less than equal to gx. If vn is convergent, then un is convergent. So if integration a to infinity gx dx is convergent, then integration a to infinity fx dx is also convergent. Take number 2, if fx greater than equal to gx and integration a to infinity gx dx is divergent, then we conclude that integration a to infinity fx dx is also divergent. Okay, clear? So now we discuss an important comparison integral. So it is a very, very important theorem. So note down an important comparison integral. Theorem. The improper integral integration a to infinity dx by x to the power n dx by x to the power n, where a greater than 0 is convergent if n greater than 1 and divergent if n less than 1. Proof. So it is a very, very important test. Integration a to infinity dx by x to the power n. So this is an improper integral of first kind. This is convergent if n greater than 1 and is divergent if n less than 1. Okay. Proof. So integration a to infinity dx by x to the power n. Okay. So this can be written as limit epsilon tending to 0 a to 1 by epsilon. আমরা লিখতে পারি দেখো 1 by 0, that is infinity. ঠিক, 1 by 0, that is infinity. So ultimately a to infinity হয়ে গেছে। ঠিক, dx by x to the power n. ওকে, দেখো x to the power n এটাকে আমরা 1 by x to the power n. So 1 by x to the power n, that means x to the power minus n. So x to the power minus n কে ইন্টিগ্রেশন করলে তুমি কি পাবে? x to the power minus n plus 1 divided by minus n plus 1. ঠিক, so this equal to limit epsilon tending to 0. So 1 by x to the power n কে আমি ইন্টিগ্রেশন করছি। So what we get? So we get x to the power 1 minus n divided by 1 minus n. Okay, so 1 by 1 minus n into x to the power minus n plus 1. Limit is a to 1 by epsilon. Okay, so now we put upper limit as well as lower limit. So that equal to limit epsilon tends to 0 1 by 1 minus n. ঠিক, so this equal, দেখো আমি যখন আপার লিমিট পুট করব, so that is 1 by epsilon to the power কি হবে minus n plus right ঠিক আমি আপার লিমিট পুট করছি সো x is equal to আমি কি পুট করব 1 by epsilon so 1 by epsilon to the power minus n plus 1 so 1 by epsilon that is epsilon to the power minus 1 right minus n plus 1 that means epsilon to the power কি হয়ে যাবে n minus 1 clear so epsilon to the power n minus 1 minus এবার লোয়ার লিমিট পুট করছি so a to the power minus n plus 1 okay ঠিক I think up to this clear so where n is not equal to 1 okay এবার খুব ভালো করে দেখবেন we know that limit x tending to 0 x to the power n so that equal to limit x tends to 0 x to the power n so this equal to undefined কখন হবে যদি n টা নেগেটিভ হয় ওকে যদি n টা পজিটিভ হয় that is if n greater than 0 that is 0 it should be note that limit x tending to 0 x to the power n that equal to 0 if n is positive and limit x tending to 0 x to the power n so this is infinity if n is less than 1 কেন দেখো n is less than 1 what কেন মানে এখানে n greater than 1 না n greater than 0 positive or negative okay so limit x tends to 0 x to the power n so that equal to 0 if n is positive and limit x tends to 0 x to the power n so that equal to infinity if n is negative কেন দেখো যদি n টা নেগেটিভ হয় তাহলে দেখো 1 by x পেয়ে যাবো ধরো n এর ভ্যালু আমি কনসিডার করছি আমি সাপোজ n is equal to -1 তাহলে তুমি কি পাচ্ছ লিমিট x tends to 0 1 by x so 1 by x that is 1 by 0 so that is undefined okay ঠিক so what is our conclusion is that limit x tends to 0 x to the power n so that equal to 0 if n is positive and limit x tends to 0 x to the power n is equal to infinity if n is negative okay ঠিক so we can write so this equal to so limit দেখো আমি যদি n minus 1 if n minus 1 is greater than 0 ঠিক তাহলে এর ভ্যালুটা কি হবে just see apply this limit x tends to 0 x to the power n is 0 if n is greater than 0 so if n minus 1 is greater than 0 ঠিক that means n greater than 1 then value of this is equal to 0 okay limit epsilon tends to 0 epsilon to the power n minus 1 so that equal to 0 if n minus 1 is greater than 0 that means n greater than 1 being my point okay ঠিক so what do we get so this equal to 0 so that equal to epsilon is equal to 0 put করছি so what do we get minus a to the power 1 minus n divided by 1 minus n okay if n is greater than 1 এবার এটা undefined কখন হবে this is undefined if n minus 1 is less than 0 therefore limit x tends to 0 x to the power that is infinity if n is less than 0 so limit epsilon tends to 0 epsilon to the power n minus 1 that is infinity if n minus 1 is less than 0 n minus 1 less than 0 that means n less than 1 okay so this is infinity if n less than 1 getting my point okay and if so what do we get so a to infinity dx by x to the power that is a finite value convergent means if we get the finite value, then we conclude that this integral is convergent. Okay, the A is finite number, so this is the finite number, so that is convergent. So we see that this integral is convergent if n greater than 1, and this is divergent if n less than 1. Okay, take. So from this we conclude that the integration a to infinity dx by x to the power n, that is convergent if n greater than 1 and divergent if n less than 1. Now what about if n is equal to 1? যদি n is equal to 1 হয় তাহলে কি হবে দেখো। So if n is equal to 1, so what do we get? So if n is equal to 1, then the integral becomes, so just you put n is equal to 1, so what we get? Then integral a to infinity dx by x to the power n, so dx by x to the power n, so that equal to integration a to infinity dx by x, because we put n is equal to 1. Getting my point? Okay, so this can be written as limit x tending to infinity integration a to x dx by x, so that is limit x tending to infinity, so dx by x, so integration of 1 by x, that is log x. Take lower limit is a, upper limit is x, so what we get? So that is limit x tending to infinity log x minus log a. Okay, so what do we get? So that equal to limit, so now put x is equal to infinity, so what do we get? Log infinity minus log a. Okay, so this is infinity, so infinity minus a finite number, so ultimately, so that is infinity. Okay, so we see that if n is equal to 1, if n is equal to 1, integration a to infinity dx by x to the power n, that is also divergent. So what is our conclusion? So we see that if n greater than 1, this is convergent. If n less than 1, this is divergent. If n is equal to 1, so that is also divergent. Okay, so you write here, so this is convergent if n greater than 1, and this is divergent if n less than or equal to 1. Okay, so this is divergent if n less than or equal to 1. So hence we conclude that hence integration a to infinity dx by x to the power n, this is convergent if n greater than 1 and divergent if n is less than or equal to 1. Okay, I think clear. So now we discuss some examples on the topic comparison test. So comparison test এর উপর আমরা কিছু এক্সাম্পল ডিসকাস করব। ওকে, সো examples based on comparison test. Example 1. Test the convergence of test the convergence of integration 2 to infinity dx divided by root over of x square minus 1. Okay, so we have to test this integral is convergent or divergent. First, we see that this is the improper integral of first kind. Okay, because the upper range of integration is infinite. Okay, so this is the improper integral of first kind. So দেখো আমি comparison test কি বলেছি, fx if fx less than equal to gx and if integration a to infinity gx dx is convergent, then we conclude that integration a to infinity fx dx is also convergent. And if fx greater than equal to gx and integration a to infinity gx dx is divergent, then integration a to infinity fx dx is also divergent. ঠিক, তার মানে দেখো আমরা যদি if fx greater than less than equal to gx and integration a to infinity gx dx, that is convergence, then a to infinity fx dx is convergent. Okay, and fx greater than equal to gx and integration a to infinity gx dx is divergent, then a to infinity fx dx is also divergent. So recall this test. Okay, so now, so answer. So here the integrand, that is fx. What is fx? Fx is 1 by root over of x square minus 1. That is our fx. Okay, so let fx is equal to 1 divided by root over of x square minus 1. ঠিক, ওকে। এবার দেখো আমরা যখন সিরিজের প্রবলেমগুলো ডিসকাস করেছিলাম, ইউএন একটা সিরিজ দেওয়া ছিল, আমরা ভিএন সিরিজটা কি করে পেতাম? ভিএন, মনে করো ইউএন একটা সিরিজ দেওয়া আছে, সাপোজ ইউএন একটা সিরিজ দেওয়া আছে, মনে করো 1/n² + 1। আমরা এখান থেকে ভিএনটা কনস্ট্রাক্ট কি করে করতাম? আমরা জাস্ট এখান থেকে n² কমন নিতাম, 1 + 1/n²। So 1/n² কে আমরা কি চুজ করতাম? vn. ঠিক, can you remember this? un একটা সিরিজ, সাপোজ un with a series, un is equal to 1/n², so আমাকে vn টা চুজ করতে হতো। ঠিক, so vn কে আমরা কি করে চুজ করতাম? আমি n² কমন নিতাম, so 1 + 1/n², so that is our vn. ঠিক, so then আমরা ক্যালকুলেশন করতে লিমিট n টেন্ডিং টু ইনফিনিটি un/vn, যে নন জিরো ফাইনাইট নাম্বার যদি হতো, if vn is convergent then un is convergent, if vn is divergent then un is divergent. ঠিক, সো আমি এখানে কনসিডার করব fx দেওয়া আছে, এটা আমি gx কে কনসিডার করছি, let gx is equal to 1/x. Okay, so we consider fx is equal to 1 by root over of x square minus 1 and gx is equal to 1/x. দেখো আমি ট্রিকটা শিখিয়ে দিচ্ছি, তা তোমরা বুঝতে সুবিধা হবে। What is fx? Just see, fx is 1 by root over of x square minus 1. ঠিক, তোমাকে gx টা কনসিডার করতে হবে। সো দেখো আমি যদি এখান থেকে x² যদি কমন নিই, so if we take x² common from denominator, so what we get? x² common, so 1 minus 1/x², so that is 1/x into root over of 1 minus 1/x². So we choose gx is 1/x. Okay, getting my point? So now, so clearly root over of x² minus 1, this term is less than root over of x² for all x is greater than equal to 2. লিখতে পারি, it is obvious. দেখো x এর ভ্যালু তুমি 2 চুজ করো, 2² 4 minus 1 থেকে root over 3 is less than, obviously less than 2. Okay, what is the value of root 3? Root 3 is 1.732. So root, just you can check. So just me x equal to 2 put karo, so 2 square minus 1. That is root over 3. Root over 3 is less than 2. Obvious. Okay. So from this we conclude that, so this implies 1 by root over of x square minus 1. So this is greater than 1 by root over of x square. That means x. Okay. So this is our fx and this is our gx. Okay. So this implies fx is greater than gx. So just see, fx is greater than or equal to gx. So if here we get fx is greater than gx. Now if we see that integration a to infinity gx dx is divergent, then we conclude that integration a to infinity fx dx is also divergent. যখন greater than তখন divergent, fx greater than gx. So if gx is divergent, then fx is also divergent. Okay? And if fx less than or equal to gx, if integration a to infinity gx dx is convergent, then integration a to infinity fx dx is also convergent. So now we have to calculate integration 2 to infinity gx dx. Okay. So now integration a to infinity. So here a is 2, so 2 to infinity. So integration 2 to infinity gx dx. So that equal to integration 2 to infinity. What is gx? Gx is 1 by x, right? So gx is 1 by x dx. Okay. Okay. So this can be written as limit x tending to infinity integration 2 to x dx by x. So that is limit x tending to infinity dx by x, that is log x. So lower limit is 2, upper limit is x. So that equal to limit x tending to infinity log x minus log. So if you put x is equal to infinity, so log infinity, that is infinity. So infinity minus a finite number. So infinity minus equal to finite number. So that will be infinity. So we see that integration 2 to infinity gx dx is divergent. So therefore the given integral is also divergent. Okay. So therefore integration 2 to infinity gx dx is divergent. Okay. So hence by comparison test, integration 2 to infinity fx dx is also divergent. Okay. So I think clear. The next example 2. So test the convergence of integration 0 to infinity cos x divided by 1 plus x square 1 plus x square dx. So answer. So what is integrand? Here fx is this. Okay. So let fx is equal to cos x divided by 1 plus x squared. Okay, then what we can write? Then fx is less than or equal to 1 by 1 plus x squared. Can? Why? Because we know that cos x is less than equal to 1. Okay, so for cos x is less than or equal to 1 for all x belongs to 0, so we consider this is gx. Okay. So ultimately what is, so we get fx is less than or equal to gx. So now fx is less than or equal to gx. Okay. So just see, fx is less than equal to gx. So now if integration a to infinity gx dx is convergent, then we conclude that integration a to infinity fx dx is also convergent. Okay, so and integration a to infinity, here a is 0, so 0 to infinity gx dx that calculation করব, যদি এটা কনভার্জ করে তাহলে বলবো 0 to infinity fx is also convergent. Okay, so 0 to infinity gx dx, so 0 to infinity, what is gx? Gx is 1 by 1 plus x squared, 1 by 1 plus x squared dx. Okay, so 1 by x squared ke integration korle ki hobe, tan inverse x. Okay, so 0 to infinity, so tan inverse infinity, that is tan pi by 2, right? So this will be pi by 2 minus 0, so ultimately pi by 2, so which is a finite number. So we see that 0 to infinity gx dx, so that equal to finite number, so we conclude that integration 0 to infinity gx dx is convergent. Okay, so therefore integration 0 to infinity gx dx is convergent. So hence by comparison test, integration 0 to infinity fx dx, so what is fx? So this is fx, so 0 to infinity cos x by 1 plus x squared dx is also convergent. Okay, clear? Similar problem, test the convergence of the integral 0 to infinity cos mx divided by x square plus a square dx. একদম সেম, cos এখানে আছে ax, এখানে কি আছে cos x by 1 plus x square, এখানে আছে cos mx by x square plus a square, same problem. So first এটাকে fx consider করবে, so fx less than equal to কি হবে, fx less than equal to 1 by x square plus a square. 1/1 plus x square 1 by x square plus a square के gx consider করবে so fx less than equal to gx ঠিক so integration 0 to infinity gx dx calculation করবে এটা finite number পাবে so we conclude that integration 0 to infinity fx dx is also convergent. Okay, so next example. So example 3. Test the convergence of the convergence of the integration 0 to infinity e to the power minus x square dx. 0 to infinity e to the power minus x square dx. Okay. Answer. We have देखो 0 to infinity, just see 0 to infinity. So this can be written as 0 to 1, 1 to infinity. আমরা লিখতে পারি 0 to infinity e to the power minus x square dx. So this can be written as integration 0 to 1 e to the power minus x square dx plus 1 to infinity e to the power minus x square dx. Okay, ঠিক দেখো এটা হচ্ছে প্রপার ইন্টিগ্রাল ঠিক 0 to 1. This function, this is bounded in this integration, and here upper limit and lower limit, that is range of integration is finite. So this is a proper integral. So every proper integral must be convergent. Okay, so this integral is convergent. So we have to check only this integral. যদি এটা convergent হয়, so convergent of sum of two convergent integral, that is also convergent. Okay, so just write. So this is a proper integral, so that must be convergent. So we have to check this integral. Okay, so right, the integrand e to the power minus x square, this is fx. So this is bounded, and the range of integration and the range of integration is finite, and the range of integration is finite for the first integral, of right hand side. That is this integral. Okay, so this is convergent. So therefore integration 0 to infinity to the power minus x, therefore 0 to 1 e to the power minus x square dx is convergent. Okay, so now we have to check for this integral, that is 1 to infinity e to the power minus x square dx. Okay, so to discuss the convergence of integration 1 to infinity e to the power minus x square dx. Okay, so this is a improper integral of first kind, because the range of integration is infinite. So let fx is equal to this. Okay, So let fx is equal to e to the power minus x square. Then e to the power minus x square. So this is less than 2x e to the power minus x square. দেখো e to the power minus x square এখানে আছে e to the power minus x square. x টা কোন ইন্টারভ্যাল লাই করবে? x lies between 1 to infinity. তার মানে x must be positive. x belongs to 1 to infinity. ঠিক, so x must be positive. ঠিক, তাহলে এই নাম্বারটা দেখো, এই তাহলে this number is always less than this number. এখন কোশ্চেনটা হচ্ছে আমি কেন 2x দিয়ে মাল্টিপ্লাই, আমি তো 3x ও কনসিডার করতে পারতাম কিনা? e to the power minus x square, this is less than 3x e to the power minus x square also. ঠিক, আমি কেন 2 নিচ্ছি তার কারণটা একটু পরেই বুঝতে পারবে। জাস্ট দেখো e to the power minus, this is less than, আমি কি লিখছি 2x e to the power minus হবে এটা, কারণ x টা হচ্ছে 1 আর x belongs to 1 to infinity, এই ইন্টারভ্যাল x টা লাই করছে, তো x must be positive. এই দেখো এই নাম্বারটা এই নাম্বারটা সেম, তাহলে জাস্ট এখানে 2x দিয়ে মাল্টিপ্লাই করা হচ্ছে, তাহলে এই নাম্বারটা অবশ্যই বড় হবে। ঠিক, এবার কেন আমি 2x দিয়ে মাল্টিপ্লাই করলাম তার কারণটা একটু পরেই বুঝতে পারবে। ঠিক, ফর অল x is greater than equal to 1, কেন? আমার এখানে রেঞ্জ অফ ইন্টিগ্রেশন ইজ 1 to infinity, that is x belongs to this interval. ওকে, এই কারণে এই নাম্বারটা পজিটিভ, obviously this is less than this number. ঠিক, so we consider this is gx. So let we take gx is equal to 2x e to the power minus x square. Then what do we get? Then fx, this is fx, then fx is less than gx. Okay, for all x greater than or equal to 1. ঠিক, so just see fx is less than or equal to gx, so we have to check integration a to infinity gx dx is convergent or not, right? So now and integration here a to infinity 1 to infinity gx dx. Okay, so that equal to integration 1 to infinity of gx কোনটা কনসিডার করি 2x e to the power minus x square. Okay, so this is our gx. দেখো কেন কনসিডার করছি, দেখো আমি এটা ইন্টিগ্রেশন করতে সুবিধা হবে, আমি যখন ইন্টিগ্রেশন করব x স্কয়ার কি কনসিডার করব, we put x square is equal to t, so that means 2x dx, so that equal to dt. দেখো 2x চলে আসছে, দেখো 2x dx যেমন dt লিখতে পারবো। যদি তুমি 3 দিয়ে মাল্টিপ্লাই করতে তাহলে ফ্র্যাকশন আছে, হতো না কেন? অবশ্যই হতো, আমার সুবিধার জন্য আমি 2x দিয়ে মাল্টিপ্লাই করছি। ওকে, ঠিক আছে, এই কারণেই দেখো আমি এখানে e to the power minus x square, this is less than 2x e to the power minus x square, আমি 3x লিখিনি, 3x লিখলেও হবে, কোনো অসুবিধা নেই। ওকে, so now when x is equal to 1, t is equal to 1, when x is equal to infinity, t is equal to infinity, so integration 1 to infinity. Okay, so 2x dx, that means dt e to the power minus x square, that is e to the power minus t. ঠিক, so this can be written as limit t tending to infinity integration 1 to t e to the power minus t dt লিখতে পারি আমরা। ঠিক, so that equal to limit t tending to infinity e to the power minus t কে ইন্টিগ্রেশন করলে কি হবে, মাইনাস e to the power minus t, 1 to t. Now put the upper limit. So that equal to limit t tending to infinity. So just put upper limit. So minus e to the power minus t, minus e to the power minus t, plus e to the power minus 1. So we know that limit t tends to infinity e to the power minus t, that is 0. But limit t tending to infinity e to the power t, that goes to infinity. Cannot come e to the power minus t, that is 1 by e to the power t. E to the power t, that goes to infinity. So 1 by infinity, that goes to 0. Okay, so ultimately what we get? So we get this is 0. 0 plus 1 by e. So 0 plus 1 by e. That means 1 by e. So which is a finite number. So we conclude that this integral is convergent. Take. So since this is convergent, so integration a to infinity fx dx is also convergent. Take. Gx is convergent, so integration 1 to infinity fx dx is also convergent. Okay. Now apply comparison test. We see that integration 1 to infinity gx dx is convergent. So integration 1 to infinity fx dx is also convergent. So by comparison test, integration 1 to infinity gx dx is also convergent. So we see that this is convergent and also this is convergent. So sum of two convergent integral is also convergent. Okay, so we conclude that the given integral 0 to infinity e to the power minus x squared dx is also convergent. Okay, so hence integration 0 to infinity e to the power minus x squared dx is convergent. Clear? Oh. Test the convergence of number 1, integration a to infinity sine square x divided by x square dx. Number 2, integration a to infinity dx divided by x root over 1 plus x square. X root over 1 plus x square. So answer. Number 1. So here integrand, that is fx, is sine squared x by x squared. Okay. So let fx is sine squared x by x squared. We know that sine squared x is always less than equal to 1. So then we can write fx is less than or equal to 1 by x squared. Since since sin square x less than or equal to. Okay, ठीक. So now we take, this is gx, so we take gx is equal to 1 by x square. ठीक. So therefore, so what we get? So we get fx is less than or equal to gx, right? For all x greater than or equal to a. Here the lower limit is a. Okay. So now we have to check integration a to infinity gx dx is convergent or not. So if integration a to infinity gx dx is convergent, so by comparison test we conclude that integration a to infinity fx dx is also convergent. Okay, so and integration a to infinity gx dx, so that equal to integration a to infinity, what is gx? Gx is 1 by x square, so dx by x square. So this is convergent. Why? We know this result. Integration a to infinity dx by x to the power n, this is convergent if n greater than 1, right? Dx by x to the power n, this is convergent if n greater than 1. দেখো এখানে n কত? 2 আছে, so this is greater than 1. So we conclude that the integral, so let's see, a to infinity dx by x square, so here n is 2, so this is greater than 1, so this is convergent. Clear? So this is convergent. Getting my point? We know that integration a to infinity dx by x to the power n, this is convergent if n greater than 1, and this is divergent if n less than or equal to 1. Okay, so here n is 2, so which is greater than 1, so this integral is convergent. You can write here, since we know that, right here, since integration a to infinity dx by x to the power n, this is convergent if n greater than 1 and divergent if n less than or equal to. Note this point. So we get a to infinity dx, a to infinity gx dx is convergent. So hence by comparison test, integration a to infinity fx dx is also convergent. So hence by comparison test, integration a to infinity fx dx is also convergent. Clear? Fx dx means this, a to infinity fx. What is fx? Fx is sin square x by x square. So a to infinity sin square x by x square dx is convergent. Okay, clear? So number 2, integration a to infinity dx by x root over 1 plus x square. So we take fx is equal to 1 by x root over of 1 plus x square. So number 2, let fx is equal to 1 divided by x root over x square plus 1. দেখো আমরা gx কি কনসিডার করব, খুব ভালো করে দেখুন। So here what is fx? Fx is 1 divided by x root over of x square plus 1. রাইট? সো দ্যাট ইজ, আমি কি বলেছি, এক্সটা কমন নেব, ঠিক? এক্স স্কোয়ার, দেখো রুট ওভার থেকে এক্স স্কোয়ারটা কমন নেব, সো এক্স স্কোয়ার কমন নিলে 1 প্লাস 1/x² হবে। সো এক্স রুট ওভার এক্স স্কোয়ার, দ্যাট মিনস এক্স, সো আলটিমেটলি কি হবে 1/x² into root over of 1 plus 1/x². So we choose gx is 1/x². Guess করতে পারছো? So gx is 1/x². 1/x². Okay, ঠিক? দেখো এবার, then what we can write? Obviously root over x² plus 1, this must be greater than root over x² হবে, x² plus 1, x² plus 1 is greater than x², so root over of x² plus 1 is greater than root over x². so আমি যদি x দিয়ে মাল্টিপ্লাই করি, সো এখানে x দিয়ে মাল্টিপ্লাই করব, ঠিক? সো x, সো আলটিমেটলি কি হয়ে যাচ্ছে এটা, সো দিস ইজ x², ঠিক? সো দিস ইমপ্লাইজ 1/x root over 1/x root over x² plus 1, this is less than 1/x². So we choose this is gx. Okay, so we take gx is equal to 1/x². So we see that fx is less than gx. Okay, so then fx is less than gx for all x greater than equal to, and integration a to infinity gx dx, so that is integration a to infinity. What is gx? Gx is 1/x², so dx by x². We know that integration a to infinity dx by x to the power n, this is convergent if n greater than 1 and is divergent if n less than or equal to 1, right? So here n is 2, so this is convergent, okay? So this is convergent. Okay, because you can write here, we know that since integration a to infinity dx by x to the power n, this is convergent if n greater than 1, okay, and divergent if n less than or equal to 1. So we get a to infinity gx dx is convergent. So by comparison test, integration a to infinity fx dx is also convergent. So hence by comparison test, integration a to infinity fx dx is also convergent. Okay, so I think clear. So আজকে আমি কম্পারিজন টেস্ট ডিসকাস করলাম, নেক্সট ক্লাসে নিউ টেস্ট ডিসকাস করব। So I think all points are clear, so thank you so much, bye.